13.1, we are now on to electrical charges, and we're going to start off with a very fun, interactive, exploratory lab on static electricity charge. The materials for this aren't too difficult. In fact, for the first part, you're just going to need some aluminum foil, cut into little leaflets. That's not too hard, and the shape doesn't really matter. They do a little toothpick shape in the pictures. You got to do a circle, square, whatever. Make sure that there's some string to separate you from that, so that way you're not discharging the electric charge. You'll need a balloon, some other random materials. So I brought a plastic straw. It gives you a list of materials on the actual page. So find some of those or some things like it, and you'll be able to do these experiments just fine. So first part has students creating essentially what looks like just one leaflet on a paper clip, and it asks them to suspend that leaflet with a string. And that's important because if you're holding on to this, all that static charge can flow onto you, whereas it's very unlikely that it's going to flow from there. So that way it kind of separates this, it's isolated now. You're going to take a balloon, rub it on your hair, or have some fabric. Let's see here, in your actual kit, it has a piece of cloth. Fell down on the floor. So in your static electricity kit, you can find a nice cloth if students don't want to rub it on their hair. That might be a good alternative. I got pretty good hair for this. Just gonna rub it a little bit and then ask students to observe what happens. They should see that it tries to come towards it, but then it'll bounce off every once in a while. That's because it's taking up some of that charge. So if I build up my charge more again, we should see if I'm a certain distance, it's repelling it. And that's because they now have the same charge. Eventually it might overcome that and then touch, and then they kind of spread the charge out and you see it kind of start to stick. So a very cool kind of experiment there. Students will have to be careful how they approach to visualize how it's bouncing away. While they still have that kind of held up, if you have students take like the plastic straw, this actually worked really well. Just take a cloth and rub it, and that's kind of building up a static charge on the straw. Then you can, if I can do this without messing it up, even the plastic straw you'll find has an attractive force. It's not as big as the balloon, but you can use other materials. So it has you use a rubber, metal, use different materials to kind of see how different materials interact with it. So it's going to ask students a bunch of questions about that, and then the second half of the lab is making what's called an electroscope. There are professional ones that are in like an Erlenmeyer flask, and what it's used for is to measure the charge of the static electricity based on how much the leaflets spread apart. Hopefully you can see it, but I've got two of those aluminum foil leaves hung on a paper clip. They use some insulated wire. I didn't need the wire to be insulated for this, so paper clip worked just fine. Used a bit of electrical tape to keep it from moving around. But you hang those two leaflets so that they're kind of sitting separated a little bit. Same thing as last time, take your balloon, build up its static charge, bring it near to the paper clip, and hopefully that's picking up on camera, but those leaflets, they just go whoop, spread right apart. And so that's a pretty cool, neat effect. It asks students to bring the balloon and touch the metal, see if anything happens. I didn't notice anything happening. They're still spreading apart. That's because now I am applying the same charge onto both leaflets. So let's pretend that they're both gaining negative charges, but now they have both negative charges, so they repel each other. And so that's a pretty neat effect. Again, it's gonna have students try, hey, rub a cloth on some metal. So for example, if I do this, they're separated, touch it with the metal, and boom, they immediately went back down. So you can do a few cool experiments like that where you can discharge all those extra charges onto a piece of metal, and students can visualize what that looks like. If you need students to because you don't see any of the charges moving, there's some good simulations on Gizmos or PhET where the students can visualize the charges moving. So that might be good to pair up with this one. But in terms of materials, you have to look around a bit, but it's not too complicated. Students get to visualize it. Pretty good lab. So I hope you guys enjoy that one, and I'll catch you guys in the next video. Bye.